Hi folks, and welcome to this third video in a series of videos on exploring AI with the Raspberry Pi. In the first video we spent some time setting our Raspberry Pi up. We were using a Raspberry Pi 5 and we attached the active cooler to keep that working within nice tolerances, and we also installed Raspberry Pi OS and got that configured and updated. In the second video we took a look at the new Raspberry Pi AI camera, where in combination with a Sony sensor, we can offload neural networks onto the Raspberry Pi camera, and then we can use the Raspberry Pi camera to do some processing like object detection or boundary box creation, and then we can deliver that tensor data directly to the Pi, meaning we free the Pi up to do other sorts of processing. Today we're going to be looking at the new Raspberry Pi AI kit. So we'll begin by doing a little bit of setup on our Pi to make sure that it's up to date, and then we'll unbox and we'll assemble the AI kit onto our Pi, and we'll start looking at what we can do with that. So starting here, we're on the Raspberry Pi AI kit homepage here. So this tells you a little bit about the device. So the Raspberry Pi AI kit is based on the M2 form factor. So this is a hat, hardware attached on top, and it's got a neural processing unit sitting on the top there that allows us to be able to do roughly 13 tera operations per second tops of AI work. So pretty powerful AI processor there. So scrolling down a little bit more, we can see there's that 13 tera operations per second and the M2 hat. The way this works is that it's going to use the PCIe connector on the Pi via a ribbon cable, and the hat will sit then on top of the Pi, sitting on the GPIOs and some standoffs as well. This is specifically to be used with a Raspberry Pi 5, so you will need to do that. To get going with this, of course, you'll have needed to have run that first step of just getting your Pi all set up. Scrolling down a little bit further, we can see that this is using the Halo NPU, Neural Processing Unit, giving us that 13 tops of power. It's fully integrated into the camera stack on the Raspberry Pi as well, so we will be using the Raspberry Pi camera, a regular one. Actually, this will be the V2 camera. There is a V3, but I've got a V2 camera here. And it comes with everything you need. So it comes with standoffs, these little stacks, and also an extension block for the GPIO pins as well. There's some documents here, and you can also go ahead and go to either the Pi Hut or Pi Moroni if you want to buy one. So this is Pi Moroni, so you can come in here and you can happily buy one of these. In fact, it looks like they've got them in stock, so get one fast. It's only one per customer, but that's to be expected. These things are flying off the shelf. And then likewise, the Pi Hut, they have them in stock at $65.70 in the UK as well. So do go and support one of these two wonderful companies. I use them myself all the time. So if we go to the documentation now and scroll down, we get a little bit more about that Pi AI kit. We've already looked at a lot of that, so we can scroll through that. We get to the install section and you see that we've got some commands that we need to run here. So we need to make sure that our Pi is fully up to date and upgraded. So we can take a copy of that command. And if we go across to our Pi, once again, I've dialed in here using Tiger VNC so that we can keep this all on my PC. We can paste in our command and run that. And we can see that we're already up to date here, which makes sense because it wasn't long since I last did an update. So the next thing we need to do is check the version of our firmware on the Pi. So if we switch back to the instructions, we'll see here that if we're running anything before December 2023, then we're going to need to upgrade our firmware. And we can check the version and the date of our firmware by running the sudo rpi eeprom update. So we can copy that, and let's run that. And we can see here that we're on the Monday 23rd of September 2024 version. So this is a very up-to-date version. So we're happy enough with that. I'm going to leave it as is. There may well be updates for you. In my case, we can see that the latest release is the version that I'm on actually. So we can leave that exactly as it is. So if we switch back to the instructions again, we can see that had we needed to, there's a couple of commands here we could use to update the firmware on our Pi. So just make sure that you're using that latest version and everything should be good. So what we need to do now is we need to shut down our Pi because we're going to move on to actually fitting the AI kit. So let's do that. Okay, so our Pi is still connected to the power. We can see that with that red LED. I'm going to turn the power off. And then I'm also going to unplug my Pi from the power. And that's that. So this is the Raspberry Pi we set up in the first video. So again, we've got the active cooler fitted here. This is recommended if you're going to run any AI applications and specifically the AI kit. To the left, I've got the V2 Raspberry Pi camera. Again, there is a V3. I think this will work with everything. And then to the right, we have our AI kit. So this is the traditional square box that you'd expect from Raspberry Pi kit with a diagram of what it is that's inside. And then we can see here that it's based on the Halo 8L AI accelerator with up to 13 TOPS and the same sort of information we saw before. So let's get it out of the box and see what we have. So we have a few bits in here by the looks of it. And we can set the box aside. So we have a GPIO expander header. So this will allow us to be able to plug this into the GPIO pins on our Pi, and that'll rise the whole thing up a little bit and allow it to connect to our AI kit. And then we've got a bunch of standoffs and screws. So that's going to allow us to mount our AI kit to the Raspberry Pi. And then the fun bit, of course, in here we've got our actual M2 hat with our Halo NPU connected as well. So here we have it. So on the top here, this is the M2 hat. So this is actually a separate unit, but when you buy the AI kit, then you'll get this Halo NPU as well, already fitted. So I believe there's actually some thermal fittings underneath that as well to make that work within good thermal tolerances. And then there's a cable here which has been nicely fastened down, and this is our PCIe cable, so we'll need to connect that out to our Raspberry Pi and make that work. So there's a few things we need to do. We need to remove this cable entirely from our M2 hat and our AI kit, so we can remove that. And then we can gently, just here, you can see that there's the two little black tabs either side of this. And you see the PCIe cable has moved a little bit there. That will allow us to remove that. Now, you see the gold contacts on this one, they're at the top. So that's going to give us a hint of which way round this goes. There are some associated gold contacts on the bottom part of the cable just here. There we are. Those gold pins there. We need to make sure that these gold pins are facing towards the USB ports on our Raspberry Pi, so to the inside of the Raspberry Pi. And just here, on the end of our Raspberry Pi, that is the PCIe connector. Now, all of these connectors have got little black tabs that you need to pull up. So you can see this one is actually just slightly down. So pulling that up and slightly away will allow us to push in our cable into that. So let's do that. There we go. Let's pop that in there. And so when you do that, you kind of just need to make sure that it goes in nice and smooth and nice and, there we are, like that, nice and level, so we can see that it's not at an angle whatsoever. While it's in there, you just use your thumb, you can push that down into place, and that locks that cable into place then. So just make sure it's all the way in. Don't need to push too hard, but just give it a little push, then a tug, just like we did with the camera before, to make sure that that is now in, and that looks okay. So next thing we need to do is we need to fit the various posts that are going to allow us to mount our AI kit to the top of the Raspberry Pi. So we'll find in here all of our posts and screws, so we can do that. Let's empty them out. So you could use a screwdriver for these. I'm going to be using these smaller screws. So there's a couple of different types of screw here, you'll notice. There's some long ones, that length, and then there's some short ones that are that length. So I'm going to be using those short ones, and we need to take a screw. I'm going to take these really short ones. It probably doesn't matter which way round we do this. We should have enough of those screws for us to be able to carry out what we need to carry out. So we'll separate out them ones, slightly shorter ones like that. So these particular posts that we've got here, they're going to go in these holes. So these are the mounting holes for our AI kit. So let's put a screw in through the bottom like that and poke it out, and then just by hand we can push in, or rather screw in, our post. It just needs to be hand tight. You don't need to go mad, it just needs to be secure. So we can do that again across on this side. Just right. So that's good. So the next thing we need to do is we need to add our GPIO riser, and that's because this AI hat is going to sit down like that on these posts, and we need to extend those GPIO pins out. As you can see, it just won't reach if we do that. So we need the extender to help us with that job. One thing to check is that all of your pins are lined up. See, that one on the end of mine is ever so slightly out. So it's good to make sure that all of your pins are level when you do this, because it's going to cause you a bit of grief if you don't. Doesn't matter which way round you do this, because it's not keyed. Its only job is to extend those GPIO pins out. So I'm just going to move these screws over ever so slightly. We will need them again in a minute. So what we need to do is attach this GPIO riser to our pins. So make sure that forwards and backwards it's lined up, and also towards the Pi and back it's lined up as well. And then once you're happy that you've got it in the right place, then you can then just slot it down ever so gently, but it will take a little bit of pressure just to push it in like that. And then you'll kind of feel a nice positive click once it's in, and it should look kind of like that, flat up against the device. So I'm hoping that all my pins are pretty much level. They look pretty level to me, so I'm happy enough with that. So the next thing we need to do is attach our M2 hat with its Halo MPU onto here. So this is going to be sort of a multifaceted job here. I'm going to make sure that this adapter connector, cable connector rather, is pulled out far enough so I don't have to do that job in a bit when it's connected. And then we need to get this lined up just right so that those pins line up with the pins on the bottom of the hat. So you see those pins there on the left hand side? Those ones are where our GPIO pins need to line up with. So a little bit awkward, but it's not too bad. So and there we are. So you'll feel it slide all the way in then at that point. So we should be able to just give it a nice gentle push so it reaches the posts like that. So you can see that's gone all the way down now, and those pins are actually connected the whole way through. That's as much as that needs. So the next thing you need to do now is screw the M2 hat, the AI kit essentially, onto these posts. So we have some more screws, so we can just pop them in there, and at this point a screwdriver is going to be your friend. These are Phillips screws, Posi-Drive screws, so if I hold that up to the camera you should be able to see that these are Phillips Posi-Drive screws, one or the other. So we need to pop them in there like that, and then if you've got a screwdriver, and I've got one here, you can go ahead and just give them a bit of a tighten up. Again, try not to cross thread your screws while you're doing this. And then finally, the last thing we need to do is our cable. Now that cable had managed to come undone from here, interestingly, so we'll need to put that back in again. Not quite sure how that happened. And okay, so that's in. So now we can just tighten up the brace and make sure that this is nice and snug, and it is, so that's not coming away now from either side. So that's our cable and our M2 hat and the NPU and everything all installed. So we can see we have our risers, pillars there, and then the GPIO riser in place, and our PCIe cable connected down here nicely as well. Again, remember, gold contacts go on the Pi side, go towards the USB ports, and the gold contact on the top should be going up. So either one of those should be correct, and they'll both be correct anyway. And then that's that. So we can place this down here. And the next thing we need to do is attach our camera. So again, this is the V2 camera here. There is a V3 and a V1, but I think it'll work with all of them. You'll need the correct cable. So this one, as it's labelled here, is the standard to mini. So this mini one here is what you'll need to be able to connect it to your Pi 5. And with that particular cable, you need to be pointing this towards the USB ports as well again. So we've got two display stroke camera sockets down here, CSI1 and CSI0 and CSI1. I'm going to be using CSI0 just here. And again, the gold contacts need to be facing this way when you fit that. So we can see we have some gold contacts on our cable just here, and those then need to be pointing that way. So this is going to be relatively difficult to do if you've already got the hat in place and you haven't lifted that black tab up. But it will be doable. It'll just be a little bit awkward, but I've already lifted it up, so I've kind of shortcutted that. So we can plug our cable in down here. So just make sure that when you're doing this that it's gone all the way in. You'll kind of feel that seated. It's going to be difficult to actually see it, but it will. You'll just need to make sure it's level, and then with that you can just push the bar down and make sure that that's in place. Now, it can be a little bit fiddly, so a screwdriver can help you with that. Just be careful when you're doing it, you don't nick the cable, and just make sure that you push that down so that it's nice and seated. And then check, just make sure that this doesn't come up. And then it should kind of flop that way. That's what you're looking for. So if you've got it the right way in, then it should look like that. So we've got some screws left over. There must be a use for those, but I don't know what they are. So I'm going to pop these screws away in this bag. Don't need my screwdriver anymore. So that should be everything configured hardware wise. So we can plug our power cable back in. I've not turned this back on yet. Like that. And assuming that everything is okay, and this looks like that's sticking out quite a way to me, so it does make me wonder if that's all the way in, but I guess we'll find out. You can check that. We can just release the tabs a little bit either side of that particular piece and just make sure it's snug. It feels snug to me, and then just make sure that you tighten them back in again. And okay, so that looks like we're ready to go. So if we return to the instructions, this will likely tell us we need to turn the Pi on. So I'm going to do that and dial in, and then I'll be straight back. Okay, and so I've turned my Pi on now, and I've used Targia VNC to dial back into it, and we're back in the instructions here. So what we have next is telling us here that using the active cooler is definitely recommended given the heat that's given off by the AI functions. We've done that already. And then we've connected cables, riser and pillars, and we've fitted our AI kit to the top of that, and then we've connected the cable correctly, and then congratulations, we've successfully installed the AI kit. We always must disconnect the Pi. We already did that, so that's good. So this guide will help you then onwards to set up the Raspberry Pi on our Pi 5 and enable us to run the RPiCam apps camera demos using the Halo AI Neural Network Accelerator. It does have some prerequisites. Again, we're already here, so you'll need a Raspberry Pi 5, the AI kit, 64-bit version of Raspberry Pi OS, which is what we installed in the first video, and then any official Pi camera. So the camera module 3 or the high quality camera. I am actually going to do another video where behind me I've got the high quality camera and the lens, and so there'll be a follow-up video where I'm testing it with that. But I wanted to test it first with just the boggy basic V2 camera, so we should be fine with that. It does say to attach the camera to your Pi following the install instructions. We've already done that. And then we need to follow the instructions to enable PCI Gen 3. This step's optional but highly recommended to get the best performance. So those instructions we can find here. So although it says here that it's not certified, they're telling us to do this, so we should be fine doing it. There's a couple of ways of doing it. We can actually edit the config.txt, or we can use a Raspberry config. So we need to do sudo Raspberry config, so we can take a copy of that. And then we'll need to select advanced options and then PCIe speed and then yes to enable PCI Gen 3 and then finish, and then we'll need to reboot. So let's go ahead and do that. And then we need to go down to advanced options, and then we need to go to PCIe speed, and we would like to enable this, so we can go across to yes. And now PCIe Gen 3 is enabled, so we can press OK. And then we can go across to finish. And it's going to ask us if we want to reboot, so we'll say yes to that. And there we are, there's our PIOS returned to us. So let's return to the instructions. We can see we need to install some dependencies, and that will include the Halo dependency for the AI kit. So this is going to install a kernel device driver, some middleware software, Halo Tapas core post-processing libraries, and the RPiCam apps Halo post-processing software demo stages. So a fair amount of stuff gets installed here, so let's do that. Okay, and we need to say yes. Okay, and that's installed. So we need to do a reboot now, so let's do that. Okay, and that's back again. No doubt we'll need the terminal, so let's get that open. Okay, and let's return to our instructions. So to ensure that everything's running correctly, we can run the following command. So this is halo rtcli forward control identity. If you see the output similar to the following, you've successfully installed the AI kit and its software. So it should show us that it's executing on a device. It can identify the board. We've got a board name of Halo 8 and some device architecture, serial number, part number. So let's copy that and make sure that works. Good, and that looks like that's working. So executing on device for 1, and we have protocol version 2. We have our board name of Halo 8, device architecture of Halo 8L, a serial number, part number, and product name. So that looks like that's all up and running on our Pi. Great news, so it means we've installed everything correctly. We can also run another command. Down here it says we can run the dmessage grep I halo to check the kernel logs, so let's do that. So it got lots of red halo, but I'm assuming that that's not a problem because it looks like it's not telling us it's a problem. So those logs look like it can probe and allocate device and that the device is enabled. So I'm happy enough with that as well. So it looks like our device is set up correctly. That's good news. Moving on, we can ensure that the camera is operating correctly by running the RPiCam hello -t for 10 seconds, and that will show a preview window for 10 seconds. So let's make sure that's working. My camera is just pointing at the ceiling, so it's not going to show us particularly anything interesting, but nonetheless, it will prove it's working. And good, so that's my hand. So that looks like that's working okay, so I'm happy with that. And that's finished, it's 10 seconds. Now we can run some demos. So the RPiCam apps suite of applications implements post-processing framework, and this section contains a few demo post-processing stages that highlight some of the capabilities of the AI kit, it says. They use RPiCam hello, which defaults to showing that preview window we'd already seen. However, you can use the other RPiCam apps, including RPiCam vid and RPiCam still. but you might need to add or modify some command line options to make those demos compatible. So to begin with, we need to download the processing JSON files required for the demos, it says. These determine which stages the post-processing is run through, and it configures the behavior each of those stages. So we can enable and disable, strengthen or weaken the strength of temporal filtering in the object detection demos, or we can enable output mask drawing. And so we can download the entire collection of post-processing JSON files by cloning the RPyCam apps repo. So let's do that. So this is going to use Git to clone those files onto our machine. Okay, so that was fast. So we should have an RPyCam apps directory now. And we do. And we can go into that directory and have a look what's in there. And we've got a few bits and bobs. So returning to the instructions again, we can do object detection. So it should display bounding boxes, similar to the previous video there, around objects that are detected by the neural network. You can disable the viewfinder, it says, with the -n flag to return just the pure text outputs, but we'll leave this as it is, which looks like it doesn't use that. So let's run that command and see what that does. Right, so we have the camera. We have a person. So it's detecting me. It's also detecting my microphone as a tennis racket, which is interesting. And then we'll try a pair of scissors like this. Yes, there we are. So it's detecting a pair of scissors. Okay, so that's that particular example. So we can close that one down. Alternatively, we can try another model with different trade-offs in performance and efficiency here. So we can run this with the YOLO V8 model. So let's copy that one and see how this performs with YOLO V8. Each of these models will have different positives and negatives. It'll be detecting things differently, or it'll be better at detecting some things better. So let's run this one. Okay, so you can still see an airplane, interestingly. Let's try person, so it can gets me in the corner as a person. About these scissors again. It can get scissors. It's pretty confident in those scissors, so that's good. Okay, so that seems to work okay though. So, and again, likely if I point it at myself, hello, then it will work. Now we've got a snowboard instead. I'm not quite sure how it's getting that, but nonetheless it is. Okay, so we could try another model. So we can run the YOLO X model. Okay, and then it can detect me. And we're getting chair as well, interestingly, and TV in the background. This one does seem to be detecting slightly different things. So let me just try the scissors again. It got scissors. Okay, so that one seemed to work okay as well. And then finally, we can run it with the YOLO V5 person and face model. So these are all obviously trained on different sets of data and fine-tuned in certain ways. Okay, so let's give it a face. Ah, so it can see that my face there, look, so face at 91% and a person. So that's interesting. I mean, let's have a look what this does. I'm assuming that it won't know that this is a pair of scissors. No, so it's not tuned on those sorts of objects. It's person and face, as it says on the tin. So, okay, that's cool. So, what's the next step? So we can now do image segmentation. So what it does is object detection specifically, and segments the object by drawing a color mask on the viewfinder image. So that'll be interesting. So let's run the following command using YOLO V5. Okay, so we have segmentation results and the camera. So, oh, look at that. It turns me green down there. Also, it's seen the clock in the background. And I'm not sure it's going to see much else in there. But that's interesting. So it's segmented that away. So it's spotted my Rode microphone in there as well, and the clock, as I say. So, okay, that's interesting. Okay. And then we can do pose estimation. So this demo performs a 17-point human pose estimation. So we saw a similar demo for the AI camera as well. So let's have a look at that. Ah, okay, so it can see that. Let's use this arm instead because it should be able to see that. This to me actually works better than the Raspberry Pi camera. If I move my microphone out of the way. Okay, and that looks like that works quite nicely too. So I think that might actually be the final demo. So scrolling down here, Halo has actually created a set of demos that you can run on your Raspberry Pi, and they're available in another GitHub repository. And we can also find Halo's extensive model zoo, which contains a large number of neural networks. So we'll probably save that for another video, just like exploring a bit more of the AI camera in another video as well. But I think that's probably enough for today's video. So hopefully you enjoyed that and you managed to get your AI kit installed and configured and running on your Raspberry Pi. And I'll see you again soon. Thanks, folks. Bye.